I wanted to take a look at a special limit variety that's going to be particularly useful for us when we go into our work in Chapter 2 with the derivatives. And so this arises very frequently, and so I wanted to sort of comb through this so that we get used to doing it here. Then when we move up to the next level, we have some experience with it. We're given a function. The specific function is irrelevant. We'll work through this, a couple examples with this, and maybe some other functions as well. But this is the special piece. It's the limit as delta x goes to 0. Now, delta x, let's take a quick little look at that. Remember, lowercase delta looks like this. If you hit shift on your Greek typewriter, you get capital delta, lowercase delta, uppercase delta. And so this is uppercase delta. And we regard this as if it were a single letter. Regard this as if it were one single individual letter or one single variable. This does not mean delta times x. It means delta x. It's similar to the Old English when you had, remember when they had the combined, you read Beowulf or something in high school. Remember when you had the combined letters? That's the way to think of this. Think of this as a single combined letter. And so delta x is a single individual value. And so we want to take the limit of, for a reason that will become clear later on, we want the limit f of x plus delta x, so substitute that in for the variable, minus f of x all over delta x. So let's see what we get out of this. Similar to the delta epsilon proof we did before, you start with the generic version. You start with the generic version. Style matters. Style matters. So, start with the generic version. Now substitute the specifics for our problem. We want limit, delta x goes to 0. Remember, this limit is equal to this limit. I want f of this expression, which means this expression needs to go in for that variable. So this is -4 parenthesis x plus delta x. I'm going to substitute that expression in for the argument, plus 2. So this is that piece. Minus the function. Just copy, paste the function. However, whenever you subtract a fraction, you must subtract it with parenthesis. And this negative sign needs to get distributed. If you don't put the parenthesis in, you won't likely remember to distribute that negative sign to make that a -2. And the denominator is delta x. So, direct substitution. What does direct substitution give us? If delta x goes to 0, this becomes x, -4x, plus 2, but then becomes plus 4x minus 2. This is 0 divided by 0 by direct substitution, which means we need to do some algebra, simplify, try again. And I think the algebra is pretty straightforward. Distribute and combine all the stuff in the numerator. Now what happens when we distribute this? Delta x is a single letter, and then minus negative is plus, minus positive is negative. This is like an accordion. It expands out, and then a bunch of stuff cancels and expands, and it comes back in. So this is the expansion out, and here is the key. If you have done the algebra correctly, any term in the numerator that does not have delta x should cancel out. If it doesn't, you made a mistake, go back and fix it. So, -4x, there's plus 4x, that's out. That has delta x, leave it alone. Plus 2, minus 2. Any term that does not have delta x should cancel out. If you still have some non-delta x terms in here, in this kind of a process, you made a mistake, go back and fix it. All right? So let's see what we have out of this. What survives this winnowing process is the only thing in the numerator is -4 delta x over delta x, and now those cancel. And the limit of a constant is the constant. So that's the procedure. Now, the devil's in the details. As these functions get a little more complicated, there's a little bit more to do here. So in the next video, I'll do another example with a little bit more involved function. The algebra gets a little more hassly, but the procedure, the overall structure is very similar, and it's going to work out similar to this process. Again, this notion of any term, this expands out, any term that does not have delta x cancels, and it contracts back in. And so in this case, our result, the limit is -4.